Greetings, sir, and hello everyone who's watching this video. My name is Chai Chan. I'm a sophomore student from the Department of Civil Engineering, and today I'm recording this video for the term project of Calculus 2. I'll be covering section 10.10, which is the binomial series and the application of Taylor series. So without any further ado, let's get started with the binomial series and the application of Taylor series. I'll be covering 4 sections. First one is going to be the binomial series itself. And then I'm covering the application of Taylor series, which include evaluating integral, evaluating limits, and calculating sum. So for the binomial series, now let's say we have a function f of x is equal to 1 plus x squared, x to the power of 2. Then we know that we can solve this in the Taylor series, and it would generate an answer of this. Now, over here on, it would be easy, right? This is 1 plus x to the power of 2. This is 1 plus x to the power of k. So if we set k equal to 2, just substitute it in, and then we get our answer here. So this is called the binomial series. Any exercise similar to this, these are binomial series. And so the binomial series that for x between -1 and 1, we have 1 plus x to the power of k here would equal to this. So to get to know this formula even better, let's take a look at the first example. First, we got f of x equal to 1 plus x, and then it's also in the square root. And now this is our binomial formula that we have. Now, in this f of x, we know that it can be written to something else. We know that square root of x is equal to x to the power of 1 over 2. This thing can be written as 1 plus x to the power of 1 over 2 as well. Now, once you get that, here it is. We can simply just replace this, substitute it into this formula. Now k will equal to 1 over 2. Now this is what we'll get. So to make things more simply to do, we can see here there's like 2 here, so this 2 multiplied together would make 2 square, right? There's 3 here, there's 2 cube, and to the power of 4. Then we know that it's in the denominator part, so we can just throw it to the bottom, and this is what we'll get. And once we get that, we can now continue to write the sum formula of this exercise. So it started with -1 to the power of n plus 1. Put this because if we multiply this in, we know that here the sign would alternate, so we have positive, and this thing would be back to negative. This thing would be positive and then negative again. So we put this because let's say n is equal to 1, then we would be -1 squared, that would be positive. And then if it's like n equal to 2, right, so you get -1 over 4, and then you get, you know, more you get like positive. Okay, so and then we time it by 1 times 3 times 5. This is because of this, you can see here. So -1, then swap to -3, and then -5. And over 2n times n factorial, this is just the denominator part. Okay, that is it for the binomial series. Now let's go on to evaluating integral using Taylor series. So this is our integral 0.0 to 0.2 sine x squared. Now the Taylor series of x is this. So then we can safely say that the Taylor series of sine x squared would be just this part squared up. So once we get that part squared up, this is what we get. Then we can just substitute it in the integral itself, replacing sine x squared, and then just integrate it. Then you get like x power 3 over 3 minus x power 7 over 7 times 6 factorial plus x to the power of 11 over 11 times 10 factorial, and this thing would, you know, continue on. But this thing, they want us to evaluate the integral with an error magnitude of less than 10 to the power of -3 or 0.001. So how do we do this? So to find or to know that if your magnitude of error is less than that, you simply have to put the number that was given in the integral somewhere. So if we try to put it in 7, so it will be 0 0.2 times 7 over 7 factorial, right? So what we'll get is this number. And yeah, that is it. That is our magnitude of error. And if we put 0 0.2 in the first one here, we get 0 0.2 to the power 3 over 3 factorial, and then we get 0 0.001, which is close to this, but a bit more. So if we find the error magnitude, then we take every value that is on the left side of that. Now, take a look at another example. Next one is going to be similar to that, so, except now we will have cos or sine. We have the square root of 1 plus x to the power 4. Now, this is our, again, binomial series. We know that square root of 1 plus x to the power 4 can be written as this 1 plus x to the power 4 over 1 over 2. And once we get that, we can simply just replace it like last time, except this time our x is to the power 4. So now we won't have just this 1 plus x, we have 1 plus x to the power 4. And this thing will be time it. So after we do that, this is what we'll get. 1 plus x to the power 4 over 2 plus x to the power 8 over 8 plus x to the power 12 over 16. Then we can evaluate this, and what we get is the answer of 0 0.1 with a magnitude of error of 0 0.00 or like 10 to the power of minus 11 something. This is what we find out. Okay, so also another thing about this one is that the one is still with a magnitude of error less than 10 to the power minus 8. That's why we use 10 to the power minus 11 here. Okay, that's it for the integral. Now let's go to evaluating limit. This one is pretty easy. We got a limit here, e to the power of x minus 1 plus x over x squared. So again, you have to remember or know the Taylor series that's generated by e to the power of x, which is 1 plus x squared over 2 plus x2 over 3. So once we know that, we can simply just substitute it in for the e to the power of x. You see here, so minus 1 here is done, x is done. So what we got is x squared over 2 factorial plus x2 over 3 factorial. And now we can simply just try to do this. So we can write it like this: limit of x equal to 0, x squared times 1 over 2 plus and then x over 3 factorial, and etc. Right? Then we can just simplify this with this. And this is what we'll get. And then the limit produces 0, so just replace 0 into x. And we know that x starts from here, right? So everything after that will be full of x squared, x cubed, so everything will be 0. And so will be 1 over 2. Another exercise is 1 minus cos x minus x squared over 2 over x to the power 4. So again, we need to take the theory of cosine x, which is 1 minus x squared over 2 factorial plus x squared over 4 factorial minus x over 6 factorial. There are some crossing sign in here. And so now we have to replace this into the limit. And once we get that, and we calculate it, minus 1 minus x over 2, x squared over 2. And once we finish off that part, what we get is the limit of x equal to 0 of x power 4 over 4 factorial, x power 6 over 6 factorial. And you can throw the denominator to the bottom. And you can evaluate the limit here. And what we get is 1 over 24. Now that's all for the evaluating limit. Now let's go to calculating the sum. So let's say we are given a series like this, and then it wants to calculate the sum, right? So we know that the thing will be with 1 over 2 minus 1 over 2 then 2 square. The thing would continue to cube to fourth, right? So we know that it's going to be starting something with 1 over 2. So we can written in 1 over 2 here, 1 over 2 minus 1 over 2. And this thing we can just simply just put it as square, because 2 is a square and 1 can be any power that it wants. Now, once we get this, let's just recall back to the Taylor series, right? the natural logarithm of 1 minus x would be x minus x squared over 2 minus x cubed over 3 plus etc. So this would be then applied in here. We know the pattern would repeat. We got x here, x squared over 2. This 1 plus 2, this 1 over 2, right? So we wanted to write in other words like 1 over 2 and 1 over 2 squared. You can see it's in the formula. This thing will also repeat the formula as well. So the answer will be the natural logarithm of 3 over 2. Now another example. So this one is x squared minus 2x cubed plus 2 squared times x to the power 4, 2 cubed x to the power 5 over factorial. Okay, so to solve this, first let's just write it as this way. You can take the x squared out, and this is what you're left with. Now we think about e to the power of x. This is what we'll get from the Taylor series, right? So what about e minus 2x? So for e minus 2x, so for e to the power of minus 2x, we can see here, we can simply just replace this x with, of course, minus e to the power minus 2x, right? So everything will be the same except x are now replaced with 2x. Then we will continue, just on. So now with that, we can now written this instead as this. So will be x squared now times e to the power minus 2x. Why? Because e to the power minus 2x is equal to this here, and that is the sum of this exercise. So that is all for my video, and thank you for, of course, paying your attention and watching me explaining all of this. Have a great day.